but water is, and that means it can absorb a lot of different things. Like if I add sugar in here or salt and mixed it up, it would disappear and dissolve into the water. All right, so water being a solvent, which I know you're learning about that word in Roots class with Miss McCarthy, it means it can dissolve another substance. So in this case, many of us have things like this at home, like lemonade, mixtures, maybe tea. Some of us might even see coffee being drank at home. And so water is the base for all of those yummy drinks. And so if I opened up one of these, I'm gonna do the peach one that we have left over. We've already drank all those raspberry ones. Those are our favorites. But if I pour this in, and you can do the same thing at home, try that out, mix something up, and then you start mixing it. You're gonna notice all of that sugar and mixture dissolves. You can look at the bottom here, nothing's left. It's just the peach yumminess. Yummy. And now you have a fancy, yummy drink, solvent being the water, and then now you have what we call a solution. This solution is a mixture that forms when one substance dissolves in another. So in this case, the powdered sugar mixture dissolved in the water, so now we have this amazing solution that we can drink. So water can be this universal solvent that can dissolve a lot of things, and then we can enjoy them and drink them. And I'm sure over your e-learning, you've been drinking lots of fun different drinks, lemonades, and maybe even some soda or juices. Or even I like just taking a glass of water like this and just putting a little squirt of lemon juice or lime in it. Makes it a little fresher, delicious to drink, but it's because it's a universal solvent. So try out an experiment. I'm sure lunch, if you haven't had it today or dinner tonight, you can make yourself a universal solvent drink, which we call a solution. All right, that's the third type of property that water has. So capillary action, surface tension, universal solvent, 3 properties. And the last property we're going to look at is pretty exciting because it actually shows us how water can change state. So let's talk about that. So to talk about the changing state and specific heat property, we have to actually look at a couple things on the kitchen stove. So I know it's almost lunchtime here in the Lauriat house, and so we enjoy different types of food for lunch, and some of them include mac and cheese or pasta. We also like egg salad a lot, so I thought today we'd make some egg salad. Some of my eggs here. And then also we like grilled cheese sandwiches. Those are delicious. So we're going to talk about specific heat and how those work today using my stove. Now you don't need to experiment and do this unless you want to help your parents with this experiment, but this is great to show you what specific heat is and why water has a really high specific heat. And we're going to talk more about what that means, a high specific heat. Not all substances have a high specific heat. Actually, water is the second highest of all substances on our planet. Well, it's lunchtime in the Lauriat house. I'm sure today you're going to eat lunch, dinner, maybe you've already had breakfast. But I thought we would talk about specific heat in a little different way based on what we're eating for lunch. So as you think about water being a very unique substance that can exist as a solid, liquid, and gas, we can think about that actually in this experiment. So when you think about water being a solid, we hopefully think of ice, right? Frozen water. This is the same substance, H2O, 2 hydrogens and 1 oxygen, as the water we talked about earlier. That's the same substance, H2O. The molecular structure is still the same. And then you also have gas, and we're going to actually be boiling water. I turned this on. This is warming up right now. Not to the gas state yet where you can see it, so we're going to keep having that cook. I also turned on the oven to cook my grilled cheese sandwich. My girls really enjoy those. Maybe you do too. You can see that the heat is warming up both of my pots and pans, and it's warming up my grilled cheese sandwich, the bread there, and it's warming up the water that's inside my pot. Now when you think about specific heat, it's the amount of heat needed to increase the temperature of a certain mass by 1 degree Celsius. So when you think about a grilled cheese sandwich, let me see here, still needs a little more time on that side because we like it nice and toasty and warm. We want that cheese to start melting a little bit. That's what makes a grilled cheese sandwich so delicious. We also, when you think about water, okay, water being a liquid that can fill up the container in whatever shape and container it's in, right? I can look at this one. It's got water in it, but it's in a different container, but it's going to basically take the shape of whatever it's in. And the molecular structure of water is actually a lot more dense than it is in the solid form. This is unique, okay? Ice, you'd think it's going to be more solid, it's going to have the molecular structure that's a lot more dense, but it actually spreads out. Do an experiment. Use an open container with water in it, preferably not glass, maybe like a plastic water bottle. Just don't fill it up all the way to the top, and put it in your freezer. And then see and mark where the water is before you put it in the freezer. And then when you take it out, see where the ice is at the edge of where it used to be, and you'll notice that the water does something when it turns into ice or into a solid. And you're going to find that the molecular structure actually spreads out, and you're going to find that it is not as dense. Where water, as you can see, is spread out more wherever structure it is, but it's very sticky. Right? If I put my hand in it, you can see it sticks to my hand. You can see these droplets. Where ice won't do that. Okay? Oh, looks like our water's boiling. So let's look at this here. Okay, so I turn these on about this. A little bit too much toasty. I think my girls might still eat it. I don't know. I might have to end up eating it. They don't like it too hot and too toasty. But all right, I think we're good with the grilled cheese sandwich. So you can see the grilled cheese sandwich. Just took it off the skillet. Pretty hot. I'm not gonna really want to touch this yet. It's pretty warm. But if I don't eat this in the next couple minutes, this is going to actually cool off very, very quickly. Because the specific heat of this is a lot lower. Water has the second highest specific heat, and so when you look at this grilled cheese, it does not. Like, I can actually almost touch this cheese, and it doesn't burn my fingers too much. It's starting to cool off already, because I just took it off the skillet here. Okay, so this warms up very quickly. You can eat it and make it really, really easily. Where water, if I open up this, you can see here the steam coming off of it. It's evaporating. Okay, evaporation is the process by which the molecules of the surface of a liquid absorb enough energy coming from the stovetop here, and it's actually becoming a gaseous state, which we would call water vapor. So water vapor, I can feel it. If you're making lunch today, you can feel the water vapor coming off the boiling water. And that water has to reach 100 degrees Celsius before it will actually go into that gaseous state. And then if it cools enough, then it will turn back into water. So we hear this a lot with condensation. Condensation is the process of where water gets back down to 100 degrees Celsius, and then water droplets might start to form. You see this in your car, early morning, you wake up and maybe there's like frost on your car, or there's like water on your car, or maybe you are in your car breathing and you can see all that fogging taking place. That's condensation. That means that heat from inside your body is actually being outputted, and then it's absorbing onto your windshield. So what you can do here is you can see here that the condensation, the process of a gas changing back into a liquid at 100 degrees Celsius, the molecules are getting sped up really quickly and really fast, so they're really spread apart. And then they get condensed a lot to become water that's inside the pot, but then they actually will spread out a little bit more when they become ice. So again, go back to that experiment I told you to do, where you take a water bottle with water in it, put it in the freezer, mark where the water was, and then look where the ice is once it's frozen. That might take a few hours, so don't expect that to be done very quickly. So this is water in 3 states and specific heat. So if I actually wanted to go and touch this water right now, that's been off for about the same amount of time that my grilled cheese sandwich has been off. I can touch my grilled cheese sandwich and it's not going to burn me at all. It actually doesn't hurt at all. But if I put my hand in this water, I would probably have pretty severe burns. Don't do this at home. That's why I'm showing it to you, because water can hold its heat really, really well. You've seen this before. If you've ever been to the beach and you've walked out on the sand, and the sand, maybe it's the morning, it's not too hot, but you get into but you touch the water, and the water maybe is about the same temperature as the sand. But later in the day, maybe it's noon, 1 o'clock, 2 o'clock, and you're walking in the sand and it's burning your feet really, really bad. Like, it hurts so much to walk on it. You actually have to wear your flip-flops to the edge of the water, right? Because the sand is so hot. It's because the sand has warmed up very quickly throughout the day of the sun, and it warmed up really quickly, but then once the sun sets, that sand's going to cool off very quickly once that heat is gone. Where water, by the beach, if you go out later in the day, you're going to find that water's getting warmer and warmer and warmer, and then at nighttime the sun goes down and that water's still warm. Sometimes it's fun to go out to the beach and go in the water after the sun is set, because the air sometimes is cooler than the water. Some of us have experienced that before, and that's because water has this high specific heat. It holds its heat in really, really well because it's polar structure. It sticks together, it wants to hold in that heat, which makes it really, really cool. So hopefully you've learned a little bit about the structure of water, looking at capillary action, surface tension, universal solvent, and specific heat. Hey, did you know that 100 degrees Celsius is equal to 212 degrees Fahrenheit? That's really warm. Don't put your hand in that. That would not be good. All right, well, it's been so much fun talking to you guys about water, and this is just the beginning. We've hopefully been able to look at how water is such an amazing thing that God has given us. Think about how your life would be without water. You wouldn't exist. You need it to survive. You use it in every single day throughout your day. Think about all those different activities you do today that include water in them, and you'll realize that this is a pretty cool material, pretty cool molecule that we get to study in science class. So I hope that you learned a little bit today, got to do some experiments. If not, go and do some experiments right now. Try out some of these things that I've been showing you. If you use the stove, make sure you ask your parents' permission first and they're okay with that. And then I'd like you to get on Flipgrid, follow the link that is on the facts under science, and I want you to tell me 2 things. First thing I want you to tell me is your prediction on this penny. How many droplets of water is this penny going to be able to hold? What's your prediction? All right, what's your prediction on how many droplets of water this penny can hold? And I want you to tell me which experiment you did that was the most interesting to you, and what you learned from it. What property of water did you actually find to be the most interesting? Tell us why. Why did you think that property was so interesting, or why do you think God gave water that specific property? Because water is pretty amazing to have these 4 different properties that most substances do not have. Or you can even talk about the change of state. Solid, liquid, and gas. You can talk about how you think that looks, and why do you think God made that possible for water to be able to change from solid, liquid, and gas. So hopefully you had fun today. Hopefully it was a little different science class. Know that I miss you, but I'm thinking about you and I'm praying for you. And I know that we will see each other soon. For right now, I look forward to seeing your videos and seeing what you're learning about science, experiments you're doing at home. And I hope you have a great rest of your day. Talk to you later.